On November 5th, a moment arrived that would deepen one of the most profound mysteries in modern astronomy. The Virtual Telescope Project released two new images of the interstellar object known as 3I Atlas, and what these photographs revealed has left the scientific community grappling with questions that challenge our understanding of celestial mechanics. The images show Atlas as a compact, luminous source without any obvious cometary activity. No tail, no coma, no visible signs of the dramatic processes that should be occurring at this stage of its journey. Even more perplexing is that the object's appearance has remained virtually unchanged since the Hubble Space Telescope captured its likeness in July of this year. For an object that, according to calculations, should have shed at least 13% of its total mass, more than 5 billion tons of matter, the absence of any large and obvious glow is inexplicable. It defies what we know about how objects behave when they venture close to our sun. To understand the magnitude of this anomaly, consider what Harvard astrophysicist Avi Loeb has pointed out. The same imaging campaign captured Comet Lemon, an ordinary comet native to our solar system. Lemon displays exactly what we would expect: a bright, transparent tail streaming away from the sun, formed as solar radiation pressure pushes gas and dust particles into space. This is the signature of a comet responding to the intense energy of our star. Atlas, however, remains mysteriously pristine, showing none of the visual hallmarks that should accompany the massive loss of material needed to account for its extraordinary acceleration away from gravitational predictions. According to Loeb, this represents the latest piece of evidence suggesting that Atlas is fundamentally different from any natural object in our cosmic catalog. It leads us to a question that science can no longer ignore. What are we really looking at? There has been considerable confusion and misinformation surrounding Atlas and its bewildering acceleration. What follows is an examination of the actual data, an attempt to determine whether this object truly represents something extraordinary passing through our solar system, perhaps even observing us as we observe it. On October 29th, as Atlas approached Perihelion, its closest point to the Sun, something unexpected happened. The celestial body suddenly accelerated in a manner that cannot be explained by gravitational forces alone. A report from NASA's Jet Propulsion Laboratory indicated that Atlas's actual position had deviated from its predicted orbit by 4 arcseconds. This number might seem trivial, but at a distance of 203 million kilometers from the Sun, this discrepancy represents an enormous error that caught scientists off guard. Atlas is accelerating at a rate of 0.2 millimeters per second squared, which translates to being pushed out of its predicted path by more than 80 kilometers in just 1 month. The data reveal that this acceleration occurs in 2 distinct directions. There is an outward push away from the Sun at a rate of 135 kilometers per day squared, approximately 60 kilometers per month. Simultaneously, there is a lateral push at 60 kilometers per day squared, about 27 kilometers per month. In essence, Atlas is drifting in 2 directions at once, being propelled outward and sideways by forces that should not be acting upon it with such intensity. Before concerns escalated, NASA was quick to assure the public that Atlas poses no threat to Earth. This unusual orbit does not bring it into collision course with any planet, though it may make a relatively close approach to Jupiter in March of 2026, a date that astronomers are monitoring with keen interest. But what is actually accelerating Atlas? Imagine throwing a ball. Gravity pulls it along a predictable parabolic curve. But if some invisible force were to act upon it mid-flight, like tiny thrusters firing at random intervals, that trajectory would change in ways you couldn't predict using gravity alone. This is precisely what is happening with Atlas. It is no longer obeying the simple rules of celestial mechanics that govern every other object in our solar system. Something else is acting upon it. With comets, the most straightforward explanation for non-gravitational acceleration is outgassing. As a comet approaches the Sun, ice on its surface absorbs solar energy, sublimates directly from solid to gas, and is expelled into space. This expulsion acts like a natural rocket engine, creating thrust that can alter the comet's trajectory. However, what has puzzled researchers about Atlas is the sheer quantity of gas that would be required to produce the observed acceleration. It is absurdly large, far exceeding what any normal comet would release, even during its most active phases near perihelion. Could something else be at work? An unknown physical mechanism? A property of interstellar objects we have yet to understand? Or, as some have dared to suggest, could there be an artificial component to Atlas's motion? This question has ignited a firestorm of debate within the scientific community, dividing researchers between those who insist on natural explanations and those willing to consider more unconventional possibilities. This is where the mystery deepens into something truly remarkable. Avi Loeb has performed fundamental physics calculations that illuminate just how strange Atlas really is. The principle is straightforward. If you know an object's acceleration and its mass, you can calculate how much material would need to be expelled to generate that thrust through natural outgassing. Atlas is estimated to weigh at least 33 billion tons, making it substantially more massive than the first two confirmed interstellar objects ever discovered. It is between 1,000 and 1 million times heavier than either Oumuamua or Comet 2I, Borisov. Its core is believed to measure approximately 3 kilometers across, nearly 6 kilometers in total extent. Given that enormous mass and the observed acceleration, the calculations lead to a startling conclusion. To generate the necessary thrust through natural outgassing, Atlas would have to lose at least 6% of its total mass during the months surrounding perihelion. That amounts to at least 5 billion tons of gas being expelled into space. This expelled material would form an immense, extraordinarily bright cloud around the object, a coma and tail that would be virtually impossible to miss with modern telescopes. From late November through late January, dozens of ground-based observatories, along with the Hubble Space Telescope and the James Webb Space Telescope, will be trained on Atlas, scrutinizing every pixel of data. On December 19th, it will make its closest approach to Earth at a distance of 167 million miles. If the predicted gas cloud exists, we will see it. The instruments are sensitive enough to detect even trace amounts of expelled material. But if there is no sign of that gas, if Atlas remains as clean and compact as it appears now, the natural explanation collapses. We would then be forced to seriously consider that the acceleration is coming from another source, possibly even a technological one. There is precedent for this unsettling scenario. Oumuamua, the first confirmed interstellar object to pass through our solar system, also exhibited non-gravitational acceleration, yet no outgassing was ever detected. Even the extremely sensitive Spitzer Space Telescope, which observes in the infrared spectrum where warm dust and gas would be most visible, detected no signs of cometary activity. Researchers were left with a paradox. In the end, some termed it a dark comet, an object that behaves like a comet, but shows none of the observational signatures we associate with comets. The very definition of a comet hinges on outgassing, yet here was an object that defied that definition while still exhibiting comet-like acceleration. Atlas presents an even more bizarre case. It displays two additional characteristics that are extremely difficult to reconcile with natural models. The first anomaly involves its brightness behavior. As Atlas approached the Sun, it brightened at a power law exponent of -7, whereas typical comets brighten at exponents ranging from -2 to -3. This means Atlas increased in brightness roughly twice as fast as expected, based on all cometary precedents. This is an unprecedented phenomenon in the study of comets, suggesting either an unusual surface composition or a process occurring on Atlas that we have never observed before. The second anomaly concerns its color. Atlas appeared distinctly blue, bluer than the Sun itself at its closest approach. This is profoundly strange because natural dust particles typically redden the spectrum rather than shift it toward the blue. Furthermore, the surface temperature of Atlas is estimated to be about 20 times colder than the surface of the Sun. Cold surfaces emit radiation weighted toward the red end of the spectrum, following the principles of blackbody radiation. They do not glow blue. The only natural explanation that might account for this would be direct emission from ionized gases, perhaps carbon monoxide or carbon dioxide ions fluorescing under intense solar ultraviolet radiation. It is crucial to emphasize that the argument being made is not that Atlas is definitively of technological or extraterrestrial origin. Rather, this represents a test of scientific methodology. When observational data does not align with existing theory, the appropriate response is not to dismiss the data, but to rigorously explore all possible explanations, even those that might seem uncomfortable or improbable. Some scientists have argued that the data must be flawed because they cannot explain it within current frameworks. Avi Loeb and others respond that this is fundamentally bad science. You cannot discard data simply because no theory adequately accounts for it. If the predicted gas cloud fails to materialize, the question of what is propelling Atlas will remain open, and more daring hypotheses will demand serious consideration. Atlas has now become one of the strangest and most inexplicable celestial bodies ever observed within our solar system. Not only because of its unusual behavior, but because of the profound implications these anomalies carry for our understanding of physics and our place in the cosmos. Unlike any object in our records, Atlas exhibits a cascade of characteristics that have scientists questioning its very nature and origin. The first of these anomalies has been termed the impossible path. Atlas travels on an orbital trajectory that is inclined just 5 degrees relative to the ecliptic plane, the geometric plane in which all the planets orbit the Sun. In three-dimensional space, an object arriving from another star system could approach from virtually any direction. The universe is not flat, and interstellar trajectories should reflect that randomness. Yet Atlas arrives almost perfectly parallel to the plane of planetary orbits. The probability of this occurring by chance is extraordinarily small, roughly 1 in 1,000, equivalent to hitting a bullseye in the dark. Astronomers have calculated that an object from interstellar space arriving with such a precise alignment is statistically improbable. Some emerging theories suggest that this incredibly precise orbit might be the result of intentional navigation, or at least influenced by a deliberate course correction at some point in the object's past. It is difficult to reconcile such an alignment with purely random gravitational interactions with other stars during its journey through the galaxy. The second anomaly involves what can only be described as a physics-defying jet. In July and August of this year, Atlas unexpectedly produced a jet of material that was directed straight toward the Sun. This is the exact opposite of what occurs with all known comets. Solar radiation pressure and the solar wind always push cometary tails away from the Sun, creating the iconic tail that points in the anti-solar direction. This is as fundamental to cometary physics as gravity itself. Yet Atlas violated this principle. The behavior is analogous to someone running forward with their hair streaming ahead of them rather than trailing behind. It defies the basic physics of momentum transfer from solar photons and charged particles. The third anomaly concerns its size and velocity. Atlas is approximately 1 million times more massive than Oumuamua, and roughly 1,000 times more massive than Comet Borisov. Despite this enormous mass, it is moving faster than either of those objects. In astrophysics, more massive objects that originate from the same stellar neighborhood tend to move more slowly when they enter a new gravitational system. This is because they carry less kinetic energy per unit mass after escaping their parent star's gravitational influence. Yet Atlas breaks this rule entirely. Under normal conditions, its mass should correlate with a lower velocity relative to the Sun. The fact that it does not suggests either an unusual origin or an additional source of acceleration beyond what it inherited from its birth environment. Some plasma physicists have speculated that the forward-directed jet could indicate the presence of an artificial magnetic field or a plasma-based propulsion mechanism, akin to ion drive technology that humanity has only tested on small spacecraft. Such a system could theoretically redirect expelled material in ways that natural outgassing cannot. The fourth anomaly involves timing that seems almost too convenient to be coincidental. In celestial mechanics, the motions of massive bodies are governed by gravitational interactions that are entirely deterministic and indifferent to observation. Yet Atlas passed near Mars, Venus, and Jupiter, three of the most scientifically interesting bodies in our solar system, while conveniently avoiding close approach to Earth during perihelion, the moment when it should have been at its brightest and easiest to observe from our vantage point. The likelihood of this specific sequence of encounters occurring by pure chance is vanishingly small, akin to winning a cosmic lottery. This has led some researchers to suspect that the trajectory is not merely the product of random gravitational dynamics. Instead, Atlas may be following a pre-calculated route, much like a space probe designed to execute a series of planetary flybys to gather comparative data about the largest worlds in the solar system while maintaining a certain distance from the planet harboring intelligent life. Some astronomers have even hypothesized that Atlas might be conducting a systematic survey, mapping gravitational fields, magnetic environments, or even searching for electromagnetic signatures of technological civilizations. This would imply purpose, planning, and intelligence behind its motion. The fifth anomaly emerges from spectroscopic analysis, which revealed something deeply suspicious about Atlas's material composition. Spectroscopy allows us to determine the chemical makeup of distant objects by analyzing the wavelengths of light they reflect or emit. When scientists examined the spectrum of Atlas, they found that it contains a higher proportion of nickel relative to iron than is typical for natural celestial bodies. This ratio is commonly found in certain human-engineered alloys. Natural comets and asteroids typically exhibit a more random distribution of metals and minerals, reflecting the chaotic processes of planetary formation and collisional evolution. Atlas, however, displays a metallic signature that appears finely tuned, as though the material had been processed or refined, rather than formed through natural accretion in a protoplanetary disk. On Earth, elevated nickel to iron ratios are characteristic of high-temperature alloys such as Inconel or Nimonic, which are used in jet engines, gas turbines, and spacecraft components because of their exceptional strength and resistance to heat and corrosion. This similarity raises the uncomfortable question of whether the material composing Atlas might have been subjected to manufacturing or metallurgical processes. Some have speculated that it could represent the remnants of a destroyed technological structure, perhaps the outer casing of an ancient interstellar vessel or probe that suffered damage during its long journey through space. The sixth anomaly is Atlas's astonishing dryness. Comets are often described as dirty snowballs, with water ice making up 80 to 90% of their mass. Water is abundant in the outer regions of stellar systems where comets form, and it is the sublimation of this ice that drives cometary activity. Atlas, however, contains only about 4% water by mass. It is drier than the most arid deserts on Earth. This has led many experts to question whether it should even be classified as a comet at all. Infrared spectral analysis, which is highly sensitive to water vapor, has found no signs of H2O outgassing, despite Atlas's proximity to the Sun and the intense heating that should vaporize any surface ice. Some scientists have proposed that its surface may be covered by a refractory ceramic or composite layer that prevents sublimation. If this hypothesis is confirmed, it would suggest that Atlas possesses an artificial shell, a protective coating designed to shield its interior from the harsh environment of interstellar space and the intense radiation near stars. Such a feature has never been observed in any natural comet or asteroid. The seventh anomaly involves the polarization of light reflected from Atlas. Polarization is essentially the fingerprint of how light interacts with a surface. Different materials and surface textures produce distinctive polarization patterns. Atlas emits a polarization signature that has never been recorded from any natural object, including Comet Borisov, which is confirmed to be of interstellar origin and appears to be a normal icy comet in every other respect. In-depth analysis shows that the polarization pattern from Atlas is consistent with light reflecting off a metallic or geometrically flat surface with a defined angle of reflection, unlike the rough, irregular surfaces characteristic of natural celestial bodies. Some experts hypothesize that Atlas may possess reflective panels, perhaps analogous to solar arrays, or symmetrical geometric structures composed of materials with optical properties similar to manufactured metals or composites. The eighth anomaly connects Atlas to one of the greatest unsolved mysteries in the history of the search for extraterrestrial intelligence, the WOW signal. On the 15th of August 1977, astronomer Jerry Eman detected a powerful narrowband radio signal while working on the SETI project at the Big Ear Radio Telescope in Ohio. The signal lasted 72 seconds, matched the expected signature of an interstellar transmission, and was so striking that Eman wrote, "Wow," in the margin of the computer printout. The signal was never detected again despite repeated searches. Its origin remains unknown. Remarkably, both Atlas and the WOW signal originated from nearly the same region of space, close to the same celestial coordinates in the constellation Sagittarius. The probability of this being mere coincidence is extremely low, yet the precision is too striking to dismiss without investigation. Some SETI researchers have speculated that Atlas could be related to the source of the WOW signal, or that it might be an intermediate relay object, a kind of cosmic lighthouse or communication node that operates on timescales of decades or centuries. If such a network exists, Atlas could represent one node in a vast interstellar communication or monitoring system established by an ancient civilization millions of years ago. The ninth anomaly is perhaps the most visually arresting and scientifically perplexing. Atlas appears to be emitting light consistent with a temperature hotter than the surface of the Sun. Its brilliant blue coloration suggests it is radiating energy characteristic of temperatures exceeding 5,800 Kelvin, which is the effective temperature of the solar photosphere. This is simply not possible for a non-stellar object under normal conditions. There is no known natural process that could heat a comet or asteroid to such temperatures without it being engulfed by a star or undergoing internal nuclear fusion. The blue color cannot be explained by reflected sunlight alone, as reflected light would have the same color temperature as the source, and Atlas is much farther from the Sun than Mercury, which does not glow blue. This suggests that Atlas may be emitting its own light, either from internal heat or from some form of energy generation we do not yet understand. Some have speculated about advanced energy systems unknown to current human technology, perhaps involving controlled fusion, antimatter annihilation, or other exotic energy sources that exist only in theoretical physics. If all of these anomalies are confirmed through continued observation, Atlas would no longer fit any natural category. It would represent the first experimental evidence of interstellar technology. Possibilities range from an autonomous probe launched by an ancient civilization millions of years ago, to orbital monitoring equipment gathering data about our solar system, to something even more enigmatic. All theoretical frameworks remain open. December 19th may be the day when humanity obtains definitive answers about whether Atlas is merely an unusual comet or the first tangible message from another intelligence in the universe. These cascading anomalies have made Atlas the focal point of intense scientific debate. Is it an exceptionally unusual comet, shaped by rare processes we have yet to fully understand? Is it a fragment of ancient technology, a derelict artifact drifting through the galaxy? Or could it be something actively sent by another civilization designed to study star systems like ours? The answer remains frustratingly unclear, but each new piece of data adds depth to an increasingly compelling and evocative picture. The physics leaves little room for ambiguity. A substantial acceleration requires a corresponding loss of mass if that acceleration is caused by expelled material. If Atlas has accelerated at the observed rate, the mass ejected to produce that thrust must be enormous, forming a bright and extensive cloud around the object that would be unmistakable to our instruments. Without such a cloud, there is only one conclusion consistent with the data. Atlas is not behaving like a natural comet. As Atlas approaches its closest point to Earth on December 19th, hundreds of telescopes around the world, from ground-based observatories equipped with adaptive optics to space-based platforms free from atmospheric distortion, will focus their instruments on this enigmatic visitor. Scientists will search for any evidence of the 5 billion tons of gas that should have been expelled if outgassing caused the observed acceleration. They will look for spectral signatures of water vapor, carbon monoxide, carbon dioxide, ammonia, methane, and other volatiles. They will measure the extent and brightness of any coma or tail. They will monitor for jets, changes in brightness, and signs of fragmentation. But if there is no sign of that gas, if Atlas remains as compact and pristine as it has appeared in every image so far, the natural comet hypothesis will be untenable. We would then be confronting direct evidence of technology that does not originate from Earth. A propulsion system operating on principles outside our current understanding of physics. An object that might be moving with intention and purpose through our solar system. The countdown to this moment of potential discovery is being regarded by some as a milestone of historical importance. In the coming weeks, we will learn whether humanity is truly alone in the universe, or whether we are witnessing the first confirmed visitor from the stars, an emissary from a civilization that may have flourished and faded long before life emerged on Earth. If Atlas is not a comet, if it is the work of another intelligence, then the moment of December 19th could mark the greatest turning point in the history of space exploration. It would be the moment when humanity not only looked up at the sky and wondered, but realized with certainty that something out there has been looking back. The most unsettling aspect of Atlas is not what we can observe, but what remains hidden. Some scientists have speculated that Atlas may be concealing sophisticated observation or communication systems operating in frequency bands beyond the range of human detection. Radio, infrared, ultraviolet, X-ray, even gravitational wave emissions could be streaming from the object without our instruments registering them if we are not looking in the right place or do not recognize the signal structure. There is also the hypothesis that Atlas does not move randomly through space, but is executing a carefully planned survey of the entire solar system on a predetermined schedule. Perhaps its purpose is to search for signs of biological life or to assess the technological advancement of any civilizations it encounters. In some corners of the scientific and speculative community, a theory has emerged called the mirror galaxy effect. According to this idea, every time a civilization reaches a certain threshold of technological capability, particularly nuclear technology or spaceflight, an observation mechanism is activated from somewhere in interstellar space. This mechanism assesses the potential threat level that civilization poses, both to itself and to the broader cosmic community. Atlas, some argue, may be such a device, a silent sentinel dispatched to monitor and record. More daring predictions suggest that on December 19th, when Atlas makes its closest approach to Earth, it may emit a synchronization signal. This signal might not be intended for us, but rather for another destination, perhaps reporting back to a distant hub that Earth has been cataloged, that intelligent life has been confirmed, or that humanity has reached a developmental milestone. Is this confirmation that our planet has been discovered? Or is it merely another step in a millennia-long exploration program executed by an ancient civilization that seeded the galaxy with thousands or millions of such probes? For now, no one knows. Atlas continues its silent journey, hurtling through the void at an acceleration that defies easy explanation. But if the hypothesis of interstellar technology proves correct, then every time we look up at the night sky and glimpse that faint moving point of light, we are not merely observing a distant celestial body. We may be under observation ourselves, the subjects of a study conducted by intelligences whose motives and methods we can only begin to imagine. The implications are staggering. If Atlas is confirmed to be of artificial origin, it would answer one of the oldest and most profound questions ever posed by humanity. Are we alone? The answer would be a resounding no. But it would also raise 1,000 new questions. Who built it? When? Why? Is it still functional, or is it an ancient relic, a ghost ship drifting through the cosmos long after its creators have perished? Does it possess any form of intelligence or autonomy, Or is it simply a pre-programmed instrument executing instructions coded into it eons ago? The discovery of Atlas and the deepening mystery surrounding it represents a moment of transition in human history. For millennia, we have wondered about the stars. We have told stories of gods and monsters in the heavens. We have built instruments to peer deeper into space and farther back in time. We have sent our own probes to other worlds. Now, for the first time, we may be on the verge of confirming that we are not the only ones to have done so. The universe may be far more populated, far more connected, and far stranger than we ever dared to imagine. As December 19th approaches, the anticipation builds. Astronomers are refining their observation schedules. Instruments are being calibrated. Data pipelines are being tested. Every major telescope facility on Earth and in orbit will dedicate time to Atlas. The scientific community is preparing for multiple scenarios. If a massive gas cloud is detected, it will confirm that Atlas is an unusual but ultimately natural comet, and researchers will work to understand what makes it so different from other comets. If no such cloud is observed, the debate will intensify, and alternative hypotheses will gain traction. Some scientists are already preparing papers exploring the implications of a technological origin. What would such a discovery mean for our understanding of life in the universe? How should humanity respond? Should we attempt to communicate with Atlas if we believe it is a probe? Or should we remain silent, cautious of drawing attention to ourselves? These are questions that belong as much to philosophy, ethics, and policy as they do to science. The data from Atlas are forcing us to confront possibilities that were once relegated to the realm of science fiction. The object challenges our models, defies our expectations, and refuses to fit neatly into any existing category. Whether it is natural or artificial, it is teaching us that the universe is capable of producing phenomena that stretch the boundaries of our imagination. And that is perhaps the most important lesson of all. Science thrives on mystery. It advances not when everything is explained, but when we encounter something that cannot be explained, something that demands new thinking, new tools, and new frameworks. Atlas is such a challenge. It stands at the intersection of the known and the unknown, beckoning us forward into uncharted territory. The coming weeks will be pivotal. Observations will either resolve the mystery or deepen it. Either outcome will be significant. If Atlas is confirmed to be a natural object, it will expand our understanding of cometary dynamics, interstellar chemistry, and the diversity of objects that populate the galaxy. If it is something else, it will fundamentally alter our perspective on the universe and our place within it. We are living through a moment of scientific history. The data are being gathered. The analyses are underway. The world is watching, waiting for answers. And Atlas, silent and enigmatic, continues its journey through the solar system, carrying with it secrets that may soon be revealed. The mystery of Atlas is not just about one object. It is about the nature of discovery itself, about the courage required to ask uncomfortable questions and the humility required to admit that we do not have all the answers. It is about the relentless human drive to explore, to understand, and to reach beyond the familiar into the unknown. Whether Atlas is a comet or a probe, whether it is a random visitor or an emissary, it has already achieved something remarkable. It has reminded us that the universe is vast, ancient, and full of wonders we have yet to comprehend. And that, ultimately, is what drives us to look up at the stars and ask, what else is out there?